Hey everyone, welcome back to part 2 of introducing Geomatic, where I'll go through broadcasting. And just FYI, this is a follow up on the last video where I introduced reactivity, and we'll see some elements of reactivity in this video as well. I won't go through it in detail because it has been done already. My focus is going to be on broadcasting. So, without further ado, let's get started. Let me refresh this page and I'll start out with a very simple command, line AB, and it creates this line between A and B. This command line takes as input points A and B, and the whole idea of broadcasting is it allows to call the same function on an array of input X if the function was defined for input X. What it means is that if I have an array of points, let's say point P1 is a point minus 2, 2, and P2 is a point 2 and 2. And I want to join them to a point at origin. So let's say my point at origin is P3. And I want to join P3 to P1 and P2. So what I can do is I can create points array, which is an array of points P1 and P2, and I can call the line command, whose first input is, let's say it's points, and I want to join them to P3. And this command works just fine when the input is an array of points as well. And the same thing can be done with points. For example, I can use you can create an array of scalars, which are linearly spaced, evenly spaced, and I can do so by calling the linspace command. So linspace has the same signature as numpy and pytorch. The first argument is the from value. Let's say it's -3. The second argument is to value, and third argument is number of points. Let's say it's n. Note that we haven't defined n, and we can modify it later, but let's see how it looks like. So we have our x's defined, and now I can just call the point command with x's and y, and it creates these 2 points. So I believe n was initialized to a value of 2 point something, but I can change n right now, and the whole thing updates reactively. So that's pretty cool to have. And I want to use this idea to draw a visualization of an MLP, of a multi-layer perceptron, which looks something like this. And to do so, what I'll do is I'll start from a clear state, and I'll define the number of neurons first. So N0 is going to be, let's say I have 5 neurons in my first layer, and 1 is, let's say it's 8, and 2 is, let's say it's 2. Then I define, let's say I define my axes, which are, x0 is, let's say it's -3, x1 is 0, and x2 is 3. And now I want my points for each x. So y0 is going to be, let's say I use the linspace command here. I want to create points from -4 to 4. And what is the number of points I want to create? That's n0. Similarly, for y1, I want to create n1 number of points. And for y2, I want to create n2 number of points. So far, so good. And then I can just create these points. For the point command on x0 and y0. Note that x0 is a point here. It's a scalar, and y0 is an array of scalars, and it creates these points immediately. And I can do the same thing for x1 and y1. Similarly, x2 and y2. All right. Now, what I want to do is I want to join them with lines. But in this case, we have arrays of points where these arrays have different lengths. So If I try to join them in this manner, for example, I just call this P1, P7, P16. I should have renamed them. But anyway, P1 and P7, I'll get this error which says broadcast shape mismatch. And the issue is pretty obvious. We have two areas of different lengths, so we can do that. So what we can do is we can reshape. We can, for example, reshape the second array to 8, 1. And if the shape of the first array is 5 and the shape of the second array is 8, 1, broadcasting works. And then we can join them with lines. So what I'll do is I'll call this thing, let's call it layer 1 points. I'll reshape. So this thing is assigned an output of P7, which I can see here on the right-hand side. So it's P7, and the dimension should be 8 and 1. All right, now I'll join all these points with lines. So I'll join P1 with layer 1 points, and it should work. Yeah, it works. Perfect. Similarly, I can draw a line from layer 1 points to P16. P16, and it also works just fine. So this is a pretty decent example of how useful broadcasting is, because just with minimal code and with minimal knowledge of certain commands, you can get some sophisticated figures. And for the remaining time, I want to show you two more examples of broadcasting. One of them can be found under examples, and I think it's titled cardioid. Yep. So here I want to create a bunch of circles, and the envelope formed by those circles forms a shape which is called cardioid. So the way I can do it is, let's say I start out with 6 points, and I want to draw circles from each of these 5 points which pass through P1. So I calculate the distances from all these points to this point P1 and draw circles. So again, this circle here, which is circle 2, let me highlight this. So it's circle 2. This circle has this point as center, and it passes through P1. Similarly, this circle, circle 3, this one is centered at P3, and again, it passes at P1 and so on. So the way it's drawn is, I would say, quite elegant, because I did not calculate the distance of distance between P1 and each of these points individually. I just used broadcasting. So what I did was I defined these points here, and I just ran the distance command on the array of points and P1, and that gave me the array of distances, and then I used that to create circles. So I used the circle command where I passed these distances and points as arrays. And then what I can do is I can change this n, which is the number of circles or number of points, and the whole thing updates reactively. So if I increase n, the shape, the cardioid shape, becomes more and more apparent. So here, I think for n equals 20, the shape is very obvious. It looks kind of like a heart shape. But anyway, so this is one example where broadcasting makes a seemingly complicated task very easy. And the second example I want to show you can be found under store. And here again, I want to show that a parabola is an envelope of certain lines. So here you can see all the commands being run. So I start out with the n number of points. I create these points x's and y's, and these are these points, and then I just join them. So I just call the line command on arrays of points, and I get this shape immediate. And the envelope formed by these lines is a parabola, and then if I want to visualize this, I can increase the number of points. or decrease them, or do something else. I can also modify the length. So here, axis is defined from -5 to 5. I could change these parameters as well and play around with it. But that's a different topic, and it strays away from broadcasting, which is the focus of this video. Anyway, broadcasting is something you'll use very often in visualizations. And if you want to learn more about it, I think there's also an article which goes deeper into this topic. Yeah, it's called Broadcasting in Geometry. I'll leave a link to this article in the video description. That's it. Thank you.